Hello, I'm Joseph Kasser, and welcome to this podcast where the AI team does a deep dive into some application of systems thinking.
Welcome back to the deep dive. Today we are opening up a file that, honestly, it sounds a little dry at first glance. But once you peel back the cover, it is basically a battle for the soul of engineering.
It really is. I mean, we are talking about the difference between actually doing the work and just, talking about doing the work.
Right. We are talking about principles. And I don't mean moral principles like don't steal or be nice to your neighbors. I mean the heavy hitters, the actual laws of the universe.
Yeah, exactly. In science and engineering, when you say a word like principle, you are invoking names like Isaac Newton or Bernoulli.
Yeah.
You're talking about things that are mathematical, predictive, and most importantly, verifiable.
Exactly.
Yeah.
Because if I am driving across a suspension bridge, I am trusting that the engineer used the principle of, say, stress equals force divided by area.
Right.
I am not trusting that they had a really positive attitude or good stakeholder engagement. I'm trusting the math.
And that distinction right there between the math that keeps the bridge up and the management that gets the bridge built, that is the entire center of the controversy we are looking at today.
So let's introduce the subject for everyone listening. We are looking at a document from INCOSE. That's the International Council on Systems Engineering. And the document is titled simply Systems Engineering Principles.
Right. And this document was roughly 30 years in the making. INCOSE is the big global body for this discipline.
The ultimate authority, basically.
Yeah. They gathered all the experts, they debated for years, and they finally published these 15 principles which they claim are the transcendent truths of systems engineering.
Transcendent truths. I mean, that is a heavy label to drop.
It is huge. It implies these are the bedrock, the F equals ma of building complex systems.
But, and here's the hook for today's deep dive, our source material, which is this very deep, highly critical analysis of the INCOSE document, argues that these might not actually be engineering principles at all.
The critique is brutal. I mean, it suggests that INCOSE might have basically handed us a management textbook and just slapped an engineering sticker on the front cover.
So we have a mission today. We need to answer 3 hard questions based on this analysis. Number 1, do these 15 principles actually meet the strict definition of a principle?
Right.
Number 2, are they engineering or are they actually just management? And 3, and this is the one that really confuses me, if they are just management guidelines, why did hard engineering bodies like the IE and the Aerospace Institute sign off on them?
Why didn't they just send the whole thing to the Project Management Institute instead? That is the million-dollar question here.
Okay, let's unpack this. We have to start with the definition. If we are going to judge these principles, we need a standard to judge them by. So how does INCOSE define a principle in their own words?
Well, they set their own ground rules right in the preamble of the document. They said a principle must be transcendent.
Meaning it applies everywhere?
Exactly. Every system, every context, every life cycle.
Okay.
And so far, so good. Gravity applies everywhere, right? Gravity doesn't care if you're in New York or Tokyo.
Right.
But then they added a condition that the source material identifies as the fatal flaw. They explicitly stated that a principle must not be a how-to statement.
Wait, pause. A principle cannot tell you how to do something.
Explicitly, no. They say these principles inform a worldview, but they do not prescribe methods.
But isn't engineering entirely about the how? If I go to engineering school, I'm literally learning how to build things.
That is exactly the litmus test our source applies, and it argues INCOSE fails it right out of the gate.
Let's look at a real engineering principle, Ohm's law.
Voltage equals current times resistance.
Classic, right? V equals IR. Is that a how-to?
Well, yeah. It tells me exactly how to calculate voltage.
Exactly. It is prescriptive. It tells you that if you want a certain voltage, you need a certain current and a certain resistance.
It is generative, meaning you can actually use it to design a circuit that has never existed before. And most importantly, it is falsifiable.
Falsifiable, meaning you can prove it wrong in the real world.
Yes. If I measure the current and the resistance, and the voltage doesn't match the equation, I know something is very wrong. Either the universal law is broken, which is unlikely, or my circuit is broken. The principle gives me a specific way to verify reality.
So real engineering principles are tools. They're equations, they make predictions.
Correct. Now, compare that to the INCOSE definition. They purposely removed the how. They removed the math.
So what is actually left? If you take the math and the how out of engineering, aren't you just left with philosophy?
The source material calls them truisms. They are statements that are technically true, sure, but they don't actually help you solve a specific problem.
Give us an example from the document. What do these look like?
Let's look at Principle 6. It's titled Progressive Understanding.
Progressive understanding. Sounds nice. I mean, we all want to understand things better.
Right. The principle states, systems engineering seeks progressively deeper understanding.
Okay. I mean, I would certainly hope so. I'd hate for them to seek progressively deeper confusion.
Exactly. It's virtually impossible to argue with. But it's also entirely useless. And the source points out the circular logic happening here. The sub-principles basically say, to succeed, you need to understand the system. And the way to obtain understanding...
Let me guess. Is by understanding.
By relying on understanding, yes.
It's a loop. It's a total tautology.
It doesn't tell you how to gain that understanding. It doesn't give you a metric or an equation to measure how much understanding you currently have. It just says, understanding is good.
That feels like reading a fortune cookie. He who seeks knowledge will find knowledge.
Compare that to a real structural engineering principle like minimize the load path.
Right. That is a clear directive. It tells you exactly what to do with your bridge design.
Seek understanding is just vague life advice.
There was another one in the analysis that really stood out to me as being totally empty of engineering content. Principle 13.
Oh, yes. Systems engineering integrates disciplines.
Again, that sounds true on its face. When you build a modern system, you integrate software, hardware, mechanical engineers.
But apply the Rutherford test to it.
Ernest Rutherford, the physicist.
He famously said, all science is either physics or stamp collecting.
I love that quote so much. It is so arrogant, but it makes such a sharp point.
It really does. Physics explains how things happen. Stamp collecting just observes what things are.
And the source argues that Principle 13 is just stamp collecting.
It is pure stamp collecting. It essentially lists the disciplines. It says, here is a physics stamp, here is a social science stamp, here is a software stamp, and it says we should put them all in the same album.
But it doesn't give you the glue. It doesn't tell you how to stick them together.
No. It offers no equation to predict the friction between the software team and the hardware team. It offers absolutely no method to verify if the integration is actually working until it fails. It just observes that integration is a thing that happens.
So we have established that these principles don't really look like engineering. They lack the math, they lack the prediction, they lack the how. So what exactly are they?
This is where the source material did some incredibly heavy lifting. They didn't just read the principles and complain, they categorized them. They took all 35 principles and sub-principles and asked, what is this specific sentence actually talking about?
And what did the numbers say?
89% of the content is primarily management.
89%. So almost the entire foundational document.
Yes. It is talking about context, stakeholder needs, organizational structure, consensus building, budget constraints.
Okay, I have to play devil's advocate here for a second, because those things are really important. If I build a brilliant technical system, but it violates the budget, or if I completely ignore what the stakeholders actually want, the project fails.
Oh, absolutely. No one is arguing that management isn't real or isn't necessary. The argument is simply that it is not engineering.
Right, it's a different discipline.
Dealing with personnel issues, managing budgets, smoothing out information flow, handling organizational hierarchy. That is the domain of project management, or systems integration management. It is fundamentally about the process of people working together.
Not the physics of the system those people are trying to build.
Exactly. It's a massive category error. Look at Principle 12. Complex systems are engineered by complex organizations.
That sounds like the title of a sociology thesis.
Because it essentially is. It's about organizational theory. It tells you literally nothing about the thermodynamics or the code structure of the system you are building. It tells you about the office seating chart.
So this brings us to the big mystery. The part of the critique that really focuses on the industry politics, which is fascinating. INCOSE is the Council on Systems Engineering. This document was peer-reviewed. Who actually signed off on this?
This is the part that really makes you scratch your head. The reviewers included the IE, the Institute of Electrical and Electronics Engineers.
The electrical engineers.
The AIAA, the American Institute of Aeronautics and Astronautics.
The rocket scientists.
And the NDIA, the National Defense Industrial Association.
The defense contractors. So the people who build the hardest, most physically complex stuff on planet Earth.
They all endorsed it.
Why? I mean, if I hand a brilliant circuit designer a document that says, Principle 1, be aware of the organizational context, why doesn't she just say, this is garbage, give me Ohm's law?
The source implies this is the principal paradox. It suggests that INCOSE actively sought validation from its peers, the hard engineering societies, for a document that actually completely belongs to the Project Management Institute, the PMI.
The PMI, that's where the PMP certification comes from. The people who love Gantt charts and critical paths.
Exactly. If you look at the actual content,
Exactly.
stakeholders, project scope, consensus building, it is entirely PMI territory.
So why didn't INCOSE just go to the PMI in the first place?
Well, the source suggests that maybe INCOSE desperately wants to be seen as engineering, with a capital E, and not just management. There is a huge prestige difference there. But by getting the IE to sign off on management checklists and call them engineering principles, they have completely muddied the waters.
They've confused the map with the territory.
Or confused the meeting agenda with the blueprints.
Mm.
Think about the long-term implication here. If the IE says, yes, managing the organizational context is an engineering principle, then they are effectively saying that administration is engineering.
That is a very slippery slope.
It is. It risks raising a whole generation of engineers who think that if they just hold a meeting and get everyone to agree, they have engineered a solution. But consensus doesn't stop a bridge from collapsing. Physics does.
So we have a document that completely fails the definition of a principle. It's 90% management speak. And it was signed by the wrong professional bodies. Is there literally any actual engineering in it at all?
There is one single item, and the irony here is just delicious.
What is it?
The only part of the entire document that cites actual math, the Weierstrass optimization theorem and Hamilton's principle. It is not labeled as a principle.
Wait, what is it labeled as?
A hypothesis. Hypothesis 1.
You have to be kidding me. The only thing in the text that is mathematically proven is called a hypothesis, and the vague management advice is called a transcendent truth.
It is completely backward. The source argues it shows a fundamental misunderstanding of what the scientific method even is.
Okay, so we've pretty much torn this document apart, and honestly, it sounds like it deserves it. But we promised you, the listener, that we wouldn't just sit here and complain. We want to offer a better way. And the source material contrasts INCOSE with an alternative model by two experts, Kasser and Hitchens.
Right. Kasser and Hitchens. These are two heavyweights in the field who looked at the state of systems engineering and said, we need actual rigorous principles.
So how are theirs fundamentally different from INCOSE's?
The primary shift is moving from activity to solution. INCOSE focuses entirely on what the engineer does. They think about context, they seek understanding, they communicate with stakeholders.
The activity.
Right.
Yeah.
But Kasser and Hitchens focus on what the system itself must be.
Give me a concrete comparison between the two.
Okay, let's take the very first principle for both models. INCOSE Principle 1 is essentially systems engineering is context dependent.
Which basically just means it depends.
It's passive. It's a mere observation of reality. Now, Kasser and Hitchens Principle 1 is the system shall have a clear, singular objective.
Shall. That is a hard requirement word in engineering.
Exactly. It is a strict constraint. You can actually verify it. You can walk into a project war room and ask, do we have a singular objective? If the project manager says, well, we have 5 competing objectives and we are trying to synergize them, then you are explicitly violating the principle.
The source uses the Apollo program to illustrate this, and I think that's such a perfect example.
It really is. If you apply INCOSE principles to the Apollo program, you would just say, well, NASA was a complex organization and they were very aware of the Cold War context.
Which is completely true, but being aware of the Cold War didn't physically put a man on the moon.
Correct. Context does not build rockets. But if you apply Kasser and Hitchens, you immediately see the actual blueprint for success. Principle 1, singular objective. Land a man on the moon and return him safely to the Earth by the end of the decade.
Crystal clear. Zero ambiguity about what the system needs to do.
Then Kasser and Hitchens Principle 2 is all about partitioning. You break the massive system into distinct subsystems that minimize interactions with each other.
Right, so you get the Saturn V rocket, the command module, the lunar module.
Exactly. And crucially, and this is where INCOSE completely fails, Kasser and Hitchens say that each of those individual subsystems must have its own clear concept of operations, or CA in OPS.
So it's not just, hey, break the problem up. It's break it up and then rigorously define exactly how each isolated piece works before you integrate them.
It's a recipe. It tells you exactly how to structure the engineering problem. INCOSE just tells you that the problem is complex. Kasser and Hitchens tell you how to slice that complexity into manageable, verifiable pieces using clear interfaces.
That distinction right there between saying, the problem is complex, and here's exactly how you slice the complexity. That feels like the whole ballgame.
It really is. It's the core difference between a philosopher and an engineer. The philosopher marvels at the vast complexity of the universe. The engineer ignores the parts of the universe that don't matter so they can build a machine that reliably works.
So if Kasser and Hitchens have the clearly better model, the model that actually looks like the hard engineering that got us to the moon, why is the industry drifting toward the INCOSE model? Why are we seeing this massive shift toward these soft principles?
I think it's a symptom of modern systems becoming so incredibly large that literally nobody understands the whole thing anymore. When you can't possibly understand the physics of the entire internet or a global logistics network, you retreat to simply managing the people who are working on it.
It is so much easier to manage the meeting agenda than to calculate the thermal load.
Exactly. You become a bureaucrat because being a true engineer is just too hard at that scale. And stamp collecting, categorizing things, making lists, holding endless peer reviews, well, that looks a lot like work.
You produce documents. You have deliverables. You check boxes.
But are you actually generating value? Or are you just generating entropy?
Let's go back to that stamp collecting analogy one more time, because I think it's the absolute key takeaway for you listening today.
It is. A stamp collector observes, this is a red stamp, this is a blue stamp.
Yep.
They categorize what already exists in the world.
And INCOSE observed the world of engineering and essentially said, here is complexity, here are organizations, here are different disciplines.
But a postmaster, the person actually running the postal system, has to design the physical flow of mail. They have to set the hard rules. Kasser and Hitchens are providing the postmaster's guide. Establish a singular route. Define the specific drop-off points.
So the ultimate accusation from our source is that INCOSE published a stamp collector's guide to engineering and then tried to pass it off to the world as the operating manual.
And that is exactly why this is actually dangerous. If you teach a young incoming engineer that stamp collecting, just observing context and categorizing stakeholders, is the exact same thing as designing and calculating, you lose the ability to create new things.
You completely lose the generative power of principles.
Precisely. You cannot derive a revolutionary new engine design from the principle that context matters. You can derive a new engine design from the strict laws of thermodynamics.
So bringing it all back to you, the listener, why should someone who isn't a working systems engineer actually care about this academic dispute? Why does it matter if the IE signed the wrong piece of paper?
Because this gradual drift from hard, verifiable principles to soft, vibes-based management is happening everywhere. You see it in software engineering with the bloat of agile management. You see it in corporate strategy. We are slowly replacing doing the thing with endlessly talking about how we organize to do the thing.
We are optimizing the bureaucratic process, not the final product.
And when that final product is a safety-critical system, like an autonomous car or a nuclear power plant or a robotic medical device, that shift becomes actively dangerous.
Right, because if the people in charge genuinely think that consensus is an engineering principle, they might compromise on physical safety just to make all the stakeholders happy.
That is the big so what here. Real engineering principles, like gravity, they don't care about your consensus. They don't care about your beautifully color-coded stakeholder map.
Gravity absolutely does not negotiate.
And if our fundamental engineering principles are suddenly negotiable, then they aren't principles at all. They are just suggestions, and suggestions do not keep airplanes in the sky.
So your final verdict on the INCOSE document?
Look, it is a highly valuable guide for project managers. It has great advice on how not to get fired in a complex corporate environment, but it should be handed over to the PMI immediately.
But is the bedrock the foundational laws of systems engineering?
It crumbles under its own weight. It completely fails the test. It is simply not engineering.
I want to leave you with a final thought to chew on. We've seen that the big legacy institutions, the IEA, the AIAA, they were perfectly willing to endorse this massive shift toward management speak. They put their official stamp of approval on the Stamp Collector's Guide.
Which is deeply worrying for the future of the field.
So, if the traditional guardians of hard engineering are softening up, where does the actual rigor live now? Is it possible that real world-changing engineering is quietly moving out of these massive legacy institutions entirely?
That is a very provocative question. Maybe the next Apollo program won't come from a complex organization blindly following 35 vague management principles. Maybe it will come from a small, highly focused team rigidly following one singular objective.
A team that cares a whole lot more about the math than the meeting minutes.
Exactly.
Something to think about the next time you're sitting in a meeting about synergy and wondering why nothing is actually getting built. Thanks for joining us on the Deep Dive.
Stay curious and always check your math.
I hope you enjoyed today's deep dive. Why not take a moment and join the discussion in the LinkedIn group Tackling Complex Problems. Take care.